Welcome to this lesson of 10 Math Methods Prep. We're going to go through the elimination method. So that is the other main algebraic method used to solve simultaneous equations. So resource checklist, make sure you've got your calculator. So just some visual cues as we're going through this PowerPoint, the pen symbol. Our WALT for this lesson is to use the elimination method to find solutions to simultaneous equations. So once again, I'm looking for you guys to label each equation in the question clearly, and you're going to have to apply operations to the whole equation at once. So that's something we'll get into more detail later in the lesson, but you've really got to see that equation as a single thing. The elimination method can actually solve simultaneous equations very quickly in 2 steps, way less than the substitution method, and you don't have to do any of that annoying graphing. So once again, can you copy down the WALT for this lesson? So the elimination method is one of the methods used to solve simultaneous equations without graphing. So in the elimination method, we add or subtract the 2 equations so that one of the variables cancels out. So if the coefficients in front of a variable have the same sign, we subtract the equations. And if the coefficients have a different sign, we add the equations. So that's a little bit confusing just to talk about, but when we go through a problem, this will make a lot more sense. Now we're going to solve a pair of simultaneous equations using the elimination method. So our first equation is negative 2x, take 3y equals negative 9. And our second equation is 2x plus y equals 7. So I'm looking at the x variable here, and I'm looking at the coefficients. So the coefficients are the same number, but with different signs. So when the coefficients have different signs, we add the 2 equations together. So we're going to add these 2 equations together. So we're going to solve this set of simultaneous equations using the elimination method. So I'm looking at my 2 coefficients in front of my x variables. So you can see that one is negative and one is positive. So they're different signs, which means we're going to add these 2 equations together. And the first step is always label my equations. Now this is probably the most crucial in the elimination method, that we label them, because it can get really confusing. So I'm going to add the 2 equations. So I'm writing 1 plus 2, equation 1 plus equation 2. So to set this out, I just write equation 1. So I've got to include the equal sign. I'm putting an operation out here, which is a plus, because I'm adding the 2 equations together. Then I'm writing equation 2. So I've now drawn another line here, because these are 3 vertical sums that I'm now going to solve. So negative 2x plus 2x, 0x. It eliminates the x variable. That's the one we were looking at. So we're eliminating one of the variables. Negative 3y plus y, negative 2y. Now keep my equal sign. Negative 9 plus 7 is negative 2. So now I've eliminated one of the variables. So now I can solve for y, because I only have one variable. So y is equal to 1, which, I'm halfway there now. That was 1 step. So this is why the elimination method is really fast. So I'm going to use this to solve for x in one of these 2 equations. So I'm going to substitute in y equals 1 into equation 1 up here. I've just picked equation 1. You can pick equation 2 if you want to. So everywhere there is a y in here, I've written a 1 instead. So now I've only got one variable, so I'm just solving for x here. So there, I've done it. I've got my answer. 3 and 1. But remember, we've got to check. So I'm going to check with equation 2. So my left-hand side equals my right-hand side. It's following along here. So I'm just going to write over here. Three comma 1 is a solution. So that's how we use the elimination method to solve a pair of simultaneous equations. So I need two variables to be the same number, and then if they're two coefficients in front of the variables to be the same number, and then different signs means I add. If the coefficients are not the same, we need to multiply the equations so that one pair of variables have the same coefficients. So what this means is we're going to have to multiply one equation by a number so that the coefficient in front of that variable is the same as the coefficient in front of the other equation. So if we have 3x plus 1 equals 4, so we have 3 x's and a 1 on this side and 4 1s on this side. If we double everything here, so we double both sides, so we have 1, 2, 3, 4, 5, 6 x's and 1, 2, 2 1s, make 2. And we double this, so we have 8. So in this example, x is 1, so 3 plus 1 is 4, 6 plus 2 is 8. So we've remained balanced because we've doubled both sides of that equal sign. So this will become more apparent when we go through a problem where we need to multiply the equation by a number. Now we're going to solve a pair of simultaneous equations using the elimination method. So like before, we're using the elimination method, but this time you'll notice that in our first equation, we have x minus 5y equals negative 17. And in our second equation, we have 2x. So we've got different coefficients there. So we're going to have to multiply one of those equations by a number so that the coefficients have the same value. So then we can add or subtract them to use the elimination method. Okay, so now we're going to solve these two simultaneous equations using the elimination method. So as mentioned, we may have to multiply one of the equations by a number so that we can use the elimination method. Now this is where labeling our equations becomes really important. So if I keep labeling correctly, I'm not going to get confused about what equation I'm using where. So I can see here that we're going to eliminate the x's and they have the same sign but a different variable. This is a 1 if we don't write it, right? So if I multiply this 1 by 2, it'll be the same coefficient. So I can eliminate them. But I can't just multiply x. I have to multiply the whole equation by 2. So the way we write that, so equation 1 multiplied by 2. So I'm just multiplying every term by 2. So I'll get 2x take 10y equals negative 34. The important thing is every piece of that equation is multiplied by 2. Now I'm going to call this equation 3 because I'm going to be using this equation. So now looking at equation 3 and equation 2, we've got the same coefficient with the same signs. So that means I'm going to subtract. So I'm going to subtract equation 2 from equation 3. Now, I am doing this is a bigger number, and I think it's just going to be a lot easier to subtract the 5 from that. Doesn't really matter which way you do it, because we're going to eliminate x either way, but what is really important is that my laying out is really clear. So I'm doing equation 3, subtract equation 2. So I'm going to write equation 3. Then I'm going to put my operation out here, which is a subtract. Then I'm going to write equation 2. Once again, this is now 3 vertical sums. So 2x, subtract 2x, negative 10y, subtract 3y. So my equal signs carry down. Negative 34, subtract 5. So I've now eliminated the x variable. So I've got one variable now, so I can solve. But from here on, it's exactly the same as the normal elimination method. The only tricky part is here and this subtract. So I'll go through and solve for y now. So I've got y equals 3. So now I'm going to substitute this back into equation 2 to get my answer. Now it doesn't matter which equation we use now. Now we've got a variable, it doesn't matter because these are equivalent equations and this is one we started with. So I'm going to substitute y equals 3 into equation 2. So everywhere I see a y, I'm putting a 3 instead. So now I'm done. I've got my 2 variables. Once again, we are going to check. So I'm just going to check with equation 1. Once again, it doesn't matter which one I check with, but I'm just going to check with equation 1. So I'm going to use them all. Why not? So everywhere I see an x in equation 1, I'm going to put a negative 2. And everywhere I see a y in equation 1, I'm going to put a 3 instead. So now I'm just going to see if these two sides match up. So my left-hand side is equal to my right-hand side, which means this is a solution. So that's how we use the elimination method again, where we have to multiply by a number. It's called a scalar, that doesn't really matter. So we'll multiply an equation by a number, and multiply the whole equation, and it sort of looks like when we subtract. It can be a little bit confusing, but if you look at these as vertical sums, you'll be able to go through that. So there we go. So things to remember when using the elimination method. So we're going to add or subtract to cancel out one of the variables. So that could be the x, that could be the y, or if we're not using x's and y's, that could be either one of the two variables. We've just got to eliminate one of them when we add the two equations or subtract the two equations. Now, it may also be necessary to multiply one of the equations by a factor if the coefficients are not the same. So like that previous example we just went through, we had to multiply that first equation by 2. So in some instances it may be more than 2, but the process will be the same. And sometimes actually you may have to multiply both equations by a number just to use the elimination method. So just remember those two things. That wraps up this lesson. So I want you guys to complete the worksheet, the elimination method. And if you can, check out chapter 4.4 in your textbook on Jack Plus. It has a really good video that explains how to use the elimination method, because it can be very confusing. And if you do have the opportunity to do that, to have another look at another way to do it, elimination method, that'll benefit you a lot. It's also got a lot of diagrams which can help. And always, 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 always label your equations so you don't get confused. So that's all for the elimination method. You guys are going to be experts at this. It's difficult to start getting used to the elimination method, but if you just follow those rules, keep practicing, it'll be super easy.